Yeah.
Nice. Okay, so for 18, it gives you 1 over a minus r in terms of r over a. So what are you being asked to do? Expand, Matt, it's not the time. Expand the quantity about 0 in terms of the variable given. Give 4 non-zero terms. So how do you go about doing this one? How do you go about constructing this one? Yeah, the first thing you have to realize is a is a what? Is a constant. A is a constant. So type is this. What is this called? I'll rewrite it. It's a minus r to the negative 1. Yeah, what's it called? Yeah, you need the binomial expansion. Do you remember that? It was at the end of... It's been a long time, I know. We haven't really met, right? So the binomial expansion of, and I'll just write it out here for you, just so you follow it, 1 plus x to the negative 1 when x is equal to negative r over a. You know what this expansion is because it is a known binomial expansion. It is a known binomial expansion. So you write it out, but then everywhere x appears, what do you write out instead? R. Sorry, everywhere x is, you plug in negative r over a. Yes. So first, what is the binomial expansion for 1 plus x to the negative 1?
1 plus...
1 plus, yep.
Negative 1x.
Negative 1x, yep, correct.
Plus...
Hold on one sec, let him finish what he's saying, and then you can ask. Okay, plus what?
Negative 1 times negative 1 minus 1.
Negative 2 over, you got to put it over something. Yeah, there's something here. This is 1 factorial over what? 2 factorial, and this is x squared. Plus, well, the next one would be, yeah, you can do one more, I guess. Negative 1 times negative 2 times negative 3 over 3 factorial x cubed. So that right there is the binomial expansion for 1 plus x to the negative 1. That is it. So now if we want the binomial expansion for a minus r, all that is if x is equal to, okay, so if we make that substitution, let's just check this here. If we had 1 plus x to the negative 1 and we plugged in x is equal to negative r over a, what do we end up with? 1 minus what? R over a to the... Is that exactly what we have up here? It is?
No.
It's kind of. It's almost what we have. I'll just ask you this. This is not a math question. This is are these two things the same? Is this the exact same as this? No. What has been factored out? A. A has been factored out. The whole point of 10.3, I think there were 3 words I gave. Oh, what was there was the video, do you remember? Substitution. You're taking what you know, you're taking known Taylor series that are really close to what you're starting with and making a substitution. So we just have to be careful. It's not just this. What else do we have to factor out of this? This right here, I'll write it down next to it. Yes, we have to factor this. So this. How do we turn this into this?
Multiply it by 1 over a.
You multiply it by 1 over a. Thank you. That's what I was getting. You can't just multiply it by a because the negative 1 power is not tacked to it. So this right here, do you agree that these two things are equal? Yeah. Yes, they are. Okay, they are equal. Now, when we make this substitution, we're substituting into this known Taylor series. We're substituting into that known Taylor series. But what else do we have to put out over the front of this entire thing? Exactly. So we have 1 over a times, what's it going to be? Negative times. Okay, hold on. Here's the thing. You just now have to realize there's a 1 over a floating on the outside of this. So we have a 1 over a floating outside of this substitution. Let me zoom out just a little bit here so you can see it. You end up with 1 plus negative 1 times, instead of x, what are you writing? Negative r over a. Try to swear under your breath a little quieter so I don't hear it. Negative r over a squared plus negative 1 times negative 2 times negative 3 over 3 factorial times negative r over a. And cubed, thank you. And it keeps on going. How are we so far? Okay, so nice clean it. Is it really nice? This is kind of nice, because what do we know the binomial expansion for?
1 plus.
So let's go a little bit further. Hold on. So what do we have here? We have, we know it for 1 plus x to a power, to whatever power we want. Is this really, really close to that? So instead of x, what are we going to write instead? X squared over a squared. Exactly. So you use the formula for binomial expansion, and then you substitute in x squared over a squared. Now, is it okay to have halves in there? Yeah, it is. This one doesn't terminate. The other ones were nice because you got a 0 in there. And what happened once you got a 0 in the product? The rest goes away, right? These, the rest isn't going to go away. The rest, infinite number of terms, is going to keep going. So at this point right now, this right here fits the binomial expansion. Do you remember this from last week? You can use the binomial expansion formula to generate the binomial expansion when you have to the negative a half power. But then wherever x appears, what do you write in? This. We're not differentiating, so we don't have to worry about any like power or product byproducts, right? We're just substituting. We're just substituting. Okay, does anybody... You have to do the transmutation. Yes, it's a little bit annoying, yeah. Hey, I got transmuted.
What do you do with the negative 1/2?
You use the formula for binomial expansion here. Here we go. Kids, here we go. So you have this. You see this, James? Yeah, well, actually, that's good. Both James, yeah. In this case, look, P, Gordon, P is equal to negative a half. So you use this formula right here. You see this? The binomial series, 1 plus x to the p, expands to this. So you expand it with p equaling negative a half, but then wherever x is, what do you put in instead? And then my guess is it simplifies a little bit. I'll put the final answer in. The cleaned up answer for 21 turns out to be, no, that's fine. Number 7. This is 1 over 1 minus z squared. How do we know that z is a variable and not a constant, Henry? It's the only one, exactly, right? Just keep. No, it's important because things in context matter, right? Like, what could this be? That could be the 0.23. That could also be the interval 2,3. Also, as you take more and more math, certain words are going to mean different things in different fields. It's a good time. What does that almost look like? Looks like 1 minus z squared to the negative 1. So what do you expand? It's 1. Oh, negative a half. Sorry, thank you. Negative a half. Right. Negative a half. So again, what is this an expansion of? We're doing our third one of these. Yeah, you're expanding a binomial. I'm not going to do out the algebra again on these. You just have to follow the algebra. Literally just follow it, okay? I can't do another one. If you want to sit down with me and do it out, I'd be more than happy to work through one of these with you. We have 2. I will say that this, when you simplify it, oh, you have it already, don't you? 1 plus 1 over a half z squared plus 3/8. Hey, look at those same constants. Z to the 4th plus 5 over 16 z to the 6th. If you want to work on this, I'd be more than happy to work on it, actually. So this is number 22b. What were the, give me the first few terms. So e to the x plus e to the negative x. Can you give, what's the first term?
I got 2 plus...
2 plus what?
2x squared over 2 factorial.
2 plus what?
2. It's
Can you just, it's just x squared, right?
Yeah.
The second term, when you simplify it, is just x squared, right? It looks like a parabola because the second order, when you take it out to the second degree, you take 2 terms, it is a parabola. That's why. They're not asking for anything deeper than that. They literally say, for x near 0, we can approximate this by its second degree polynomial, whose graph is a parabola. That's it. Books, over on the right, you should see 10.4 exercises. I would like you to, right now, make sure you can access this page right here.